Today we will be solving equations with rational exponents in them. So I'm going to be doing the odds, and then y'all will be doing evens for your homework assignment. So whenever we are solving our rational exponent equations, it's just like solving regular equations where we want to do the opposite operation to undo whatever has been done. So whenever I see, like on number 1, where I see 27 equals x to the power of 3 over 2, in order to undo that power, I'm going to take that whole thing to the reciprocal power, because I know that anything times its reciprocal is 1. So when I take a power to a power, remember that we're going to multiply those powers together. So 3/2 times 2/3 is 1. And then 27 to the 2/3 power, we can pop that into the calculator. And we get 9. So 9 is equal to x, and then we're done. So that's one of the simple ones where we just have a power and nothing else to work with. Now on number 3, we've got x to the negative 3/2 power equals 1 over 729. So we're going to do the same thing. Since nothing is on the same side as x, we're just going to go ahead and raise that to the reciprocal power, but we got to make sure that we are raising it with the negative on it, because with the negative on there, we're going to be able to get rid of the negative, so we no longer have a negative exponent. So we'll take 1 over 729 and raise that to the power of negative 2/3. And so we get 81 as our answer. So x equals 81. On number 5, again, we have a variable to some exponent, and then we have equals a number. So we're going to undo that exponent by taking it to the reciprocal power. So instead of 5 over 4, we got 4 over 5. And so we'll take 243 and raise it to the power of 4/5. And we get 81 again. So now v equals 81. Now on number 7, we see that there is this whole quantity of n minus 27 that is being raised to the 3/2 power. So since everything is being raised to that 3/2 power, I'm going to need more space, so I'm going to rewrite it. We're going to raise that entire piece to the 2/3 power, and then 64 as well to the 2/3 power. So what happens there is I get these two to cancel. So I just have n minus 27 on the left, and then 64 to the 2/3 power is 16. So we have n minus 27 is equal to 16. And I want to solve for n, so I'll add 27. And I get n is equal to 16 plus 27, which is 43. On number 9, we have the same type of problem. So when you see a lot of signs and a lot of operations, don't get overwhelmed. Look at what's happening big picture. So big picture, we've got this whole quantity that is being raised to a power, and there's nothing going on outside of the parentheses. So the first thing we're going to do is raise everything to that reciprocal power, which would be 3/5. And just like the last one, it'll get the power to cancel out. And we'll take 3,125 to the 3/5 power. And we get 125. So we have 125 is equal to negative 1 minus 18p. Now our variable is p, so we need to get everything away from p. So we'll add 1, we get 126 is equal to negative 18p. And then I'll just divide by negative 18. And we get that p equals negative 7. Now number 11, it looks like it's going to be similar to number 9, but we don't have our pieces in parentheses now. So the first thing I need to do is make sure that my variable with that power raised to it is isolated. So I'm going to subtract 10 on both sides. I get 4b raised to the negative 3/4 power is equal to 21 over 2 minus 10 is 1/2. And so I'd be tempted to raise everything to that power now, but the problem with doing that is that that 4 is not being raised to the power of negative 3/4. So first, I would have to divide by 4. So then I would just have b to the negative 3/4 power, and that is equal to 1/2 divided by 4, which is 1/8. And now you can raise everything to the reciprocal power. Make sure the negative stays so that we can get rid of it in our answer. And we have b is equal to 1/8 raised to the negative 4/3 power, which is 16. Then on number 13, we have another one where it is not in parentheses. So on this one, again, we want to make sure that the variable is isolated first. So we get 729 is equal to v raised to the 3/2 power. And then we're going to raise everything to the reciprocal power of 2/3. So 729 raised to the 2/3 power is 81. And since v is isolated after that point, we've got v equals 81. The next one looks similar to what you did yesterday, but we're going to change this by converting. So that is 2m raised to the 1/3 power equals 30. And then we'll raise everything to the reciprocal power, which is 3 over 1, or just 3. So we get 2m is equal to, and then 30 raised to the 3rd power is 27,000. We'll divide everything by 2. I get m is equal to 13,500. So then on number 17, the last one, we see that it is in parentheses. So if this were 27p raised to the 1/2, our first step would be divide by 27. But since 27 is in that parentheses, what we're going to do is raise everything to the opposite power. So we're going to take the reciprocal. And I just did it in red because it was very close together. So we end up with 27p is equal to 81. And 27, we've got to divide it out so we can get p by itself. And that gives me that p is equal to 3. So in each of these, we are just taking, once our variable is isolated with its power, we're taking it to the opposite, not opposite, the reciprocal, sorry, the reciprocal power, and then you will get your variable solved for. So just make sure that you isolate the variable first before you get started. And then make sure that you turn this in on Canvas once you have completed it.